Okay, this is 3.7, very easy. أول شيء recognize a diprotic acid. Always diprotic from the word di is with two hydrogen. So obviously not this. This is correct. This is wrong. This is wrong. And this is correct. If they said triprotic, then it would be with H3. So this one would be wrong because it has four H's. But anything with H3 would thus be triprotic. Select the weak acids. You guys know any weak acid is the one, any COOH containing, and then H2SO3 and H2S. You must memorize these. This whole quiz, 3.7, you must memorize it all by heart. Okay. Question 3. Select the oxides that dissolve in water and produce a diprotic acid. So I don't really understand this, but from the book, I had to open the book. You have three diprotic acids that you should know in the H2SO4, H2SO3, which is sulfurous acid, and you have carbonic acid, which is, where is it? H2CO3. These are diprotic acids. What was the other one that we said? Question 2. Question 1. Yeah, H2CO3, H2SO4, as well as H2SO3. From the book, you get sulfuric acid H2SO4 when you dissolve SO3 in water. You get sulfurous acid H2SO3 when you dissolve SO2 in water. Okay? And you get carbonic acid H2CO3 when you dissolve CO2 in water. So three things that you can dissolve to get a diprotic acid are SO2, CO2, and إذا حطوا لك SO3, that would also be correct. Also, by the way, these are all bases. And this is basic because it's a metal oxide, metal oxide. They're both basic. This one also is basic. They're all basic. So obviously, it won't give you acids. And if you didn't know, by process of elimination, of course, these two will be acids. Question 4. Select the strong bases. Okay. This is an acid, nitric acid. This is sulfurous acid. This is acetic acid. Or no, it's not. This is, I don't know. What is this? I think this is ethanoic acid. Yeah, this is ethanoic acid. This is hydrochloric acid. Obviously, these are all acids. These are the only bases. Of course, they're the bases. The only weak bases you should know are MgOH and NH3. These are weak bases. Okay. Question 5. Write the balanced reaction for HNO3 in water, dissociation of HNO3 in water. I don't really see what's so hard about this question. You have HNO3. It's aqueous. Dissociates to form H plus and NO3 minus. Akid aqueous, aqueous. I don't see what's so hard. I think what they're trying to see is if you put a double arrow or not. Maybe here. Yeah, exactly. The difference between this one here and this one here, and they're both dissociation. What's the difference? Look here, there's a double arrow. Here it's a single arrow. What's the difference? When you have a double arrow, معناتها it's a partial dissociation. When you have partial dissociation, if it's a weak acid or a weak base. But there is one exception of a strong base that has a partial dissociation, and I mentioned it in a previous video. It's calcium hydroxide. Okay, you have to know that. Any weak acid or base dissociates partially, as well as the only strong exception is calcium hydroxide. It's strong base, but it partially dissociates. Okay, and CH3SOH, guys, it's very, very... Obviously, since it's an acid, the first thing, and I always write, is H plus. Acid has H plus. And I just take this H plus. What's left? Just take the H plus out. What's left? CH3COO. I keep put state symbols. Aqueous, aqueous, aqueous. Okay. Just aqueous, aqueous, aqueous. So the only difference here is that you use the double arrow. Okay. Some people will see you're dissolving it in water and they write it like this. This is wrong. I'm not reacting it with water. I'm dissolving it in water. When you dissolve something in water, you don't write plus H2O. Okay? Don't write it like that. Well, how did I do that, Mom? Question 7. Write the two-step balanced reactions for the dissociation of sulfuric acid in water. Okay. H2SO4 in water. Dissociated. Sometimes we write it like this. We say 2H plus and SO4 2 minus. We say this. This is one complete step. But whenever you have a diprotic acid, how many times does it dissociate? Obviously 2 times. Okay, but نحن for simpler matter, to make things easier, we just say to get 2H plus and SO4. We just write it like this. Okay, but actually, there's actually two steps. Each dissociation accounts for one hydrogen atom. So H2SO4 when dissociates, أول مرة it's 1H plus and then HSO4 minus. The second time this will be dissociating. It will be like this: H plus and SO4 2 minus. So here for the first one, step 1, like I wrote here, it dissociates first one H plus. Okay, you can only dissociate one H plus at a time. This is if they're asking you to yani split it up into steps. Dissociate one H plus, you're gonna be left with HSO4 minus. Why is it? See, some people will be like, oh, why minus? Look, SO4 is usually 2 minus. H plus is like plus, right? Okay, so H plus SO4 2 minus 1 minus 2 is minus 1. So the charge when you mix H and SO4 is gonna be minus 1. Or you can do it this way. H2SO4, the charge of it was 0. Okay, the charge of it was 0. You take out a plus 1. What's going to happen? It's going to be now, 0. We took out a 1. So what's going to be? Negative 1. So the charge of HSO4 is going to be negative 1. You can do it like that. Whatever do you want, whatever you want. But by the way, you need to know these charges thing for chapter 4 redox reactions. And I'm recording this for the periodic in term 1 week 10. There's chapter 4 with the reduction, oxidation, whatever. So that's the first step. The second step, you take the compound here, HSO4 minus. They're all aqueous, by the way, because we're talking about ions. And then you just take an H plus out. But this one is a partial dissociation. Why is it partial? I think they explained it in the book. Yeah. So when you dissociate first, you're now left with HSO4, which is a weak acid. Okay, it's weak. Okay, and since it's weak, obviously its dissociation will have a double arrow. Okay, so the second dissociation is weak, so it's gonna have a double arrow, and it's gonna take H plus out, and what you're gonna be left with? SO4 2 minus. It would be a good idea if you want to go through the book for the dissociations of acids, especially the diprotic ones, because they weren't really stressed on. Like for example, for H2SO4, we said it's this. This is the second dissociation. And then they said this is the overall. This is the overall dissociation. H2SO4 has a partial dissociation. For some reason, why is it partial? Because the second one is partial. Okay, remember we said the second dissociation is partial. The overall reaction dilute solution is just more. It has a double arrow. Yeah, it has a double arrow. Okay, sulfuric acid, they said, is dibasic diprotic because it gives off to proton, whatever. Sulfuric acid is produced by dissolving sulfur trioxide in water. Okay, yeah, whatever. Okay, then here, H2SO3, it's also diprotic, and we know it's weak, so it will have a partial dissociation. You can get H and HSO3, and this HSO3 in the second one is weak, so it's going to be also partial dissociation. Then phosphoric acid, H3PO4. This is triprotic. Why is it triprotic? Because it has 3. Okay, phosphoric acid is H3PO4. Okay, so dissociate. It starts as a weak acid, continues as a weak acid, continues as a weak acid. So H3PO4 dissociates. Take one out, comes H2PO4. Then take one out, comes. Hold up. Partially ionized. Okay, yeah, I don't think they'll ask this. Oh yeah, you're gonna get. I don't think they're supposed to put the 2 here, but you're gonna get this. Okay, and then when you put it in water, there's no more H. You get what I'm trying to say. Every dissociation takes one H plus out. This is acetic acid. Okay, yeah, this is weak as well, so it should be double arrow. We did it. Carbonic acid is H2CO3, diprotic. First dissociation, take one H. Where is it? Here. First dissociation, you take the H plus out. You're left with HCO3. Then you want to take this out, so you take it out. Hey, they're all partial dissociations because there are carbonic acid is weak. Okay, let's continue. Question 8. Match to identify the strength. Okay, CH3COH is obviously weak acid. KOH, any hydroxide except MgOH is strong, so strong base. H2SO4, it's a strong acid. NH3 is a weak base. CaOH2, calcium hydroxide, even though it partially dissociates, is a strong base, right? HNO3, nitric acid, is a strong acid. CO3 2 minus is a weak base. Why is this a base? Some people want to ask me, why is this a base? Anytime you see something that's negatively charged, if you have these, you consider it a base. Because technically, a base is anything that accepts protons. So akid is going to be weak because it's not a full compound. So if you see like an ion like carbonate, you're going to call it a base because it's a proton acceptor. Okay? If you saw, مثلا, let's say, NH4 plus, it's going to be considered as an acid because it's positive. Okay? So these things, they might not make sense, but if you see it negative, you know that acids are proton donors, they donate protons, but bases are proton acceptors, so they're going to be negative. So acids are going to be positive since they donate protons, and bases are going to be negative since they accept protons. Yeah, that's it. Thank you so much for watching, and good luck in your exam.